High class, we continue with the third class for lesson for sorts. Today, let's look at multiplication and division of sorts. This is very important, please. Um, you need to master these basic things about multiplication because most problems, especially for examination type questions, you cannot avoid multiplication. There are most problems you cannot avoid, just like the simplification as well. Now, let us understand that root 3 times root 3, root 5 times root 5, root x times root x, like we are having the same thing, yeah, in the irrational part inside the roots. So if you observe, the inner parts are the same, nothing outside. The inner parts are the same, there is something outside. The inner parts are different. I don't write anything outside. The inner parts are different. There is something outside. So take your time and pay attention so you understand this one once and for all. Yeah, the next class I will deal with multiplication proper, how we expand. That will be lesson 4, and lesson 5 I will consider how to rationalize the denominator or the numerator. Now, basically, it shouldn't be a rule, it shouldn't be a condition. When you have root 3 times root 3, the most important thing, both numbers are irrational. Both numbers, they are surds. If both are surds, well, you need a surd as well. So 3 times 3 is 9. I forgot to create one wherein one is a surd and the other is not. But I will create that example before the end of the video. This is a surd, this is a surd. Of course, you can see the roots. This is a surd, this is a surd. So we need a surd again. But from the basic square root, that the square root of 9 is 3. So because the same number will always give you a perfect square, we always try to avoid this step. What do we do? When the irrational parts are the same, just forget about the root and just write 3. Meaning, if you have root 5 times root 5, just say 5. No need to say root 25 when you know that square root of 25 is 5. Okay. Root 10 times root 10 is just 10. You don't need to go to root 100 when you know it will become 10 because the square root of 100 is 10. So therefore, root 3 times root 3 is just 3. We avoid this one. I only intended to decided to write this so you understand why it is this. So you have the evidence. Okay. Now, nothing is outside. Why? Because I just decided to start it that way. Now, this and this, they are the same. But this time around, there is something outside. So we deal with those outside first. We say 5 times 3, 15. This one is a sword, this one is a sword. We need a sword. Root, root 2 times root 2. A sword, a sword. We need a sword. 2 times 2 is 4. But what is the square root of 4? Is 2. This is the same thing I was emphasizing. 2 times 2 is 4. Yes, but the square root of 4 is 2. So we don't want to waste all this time. That's why I said root 3 times root 3, just say 3. Root 2 times root 2, just say 2. So if 5 times 3 is 15, root 2 times root 2 is 2. This will appear like 152, and it shouldn't be that way. Why? Because between 5 and root 2, there is a multiplication here. Between 3 and root 2, there is a multiplication here. So writing it this way, we have altered the rule of multiplication. So therefore, 5 times 3 is 15. Root 2 times root 2, yes, it is 2. But the result of those outside supposed to multiply the result of those coming from inside. So it appears like this. I hope you understand it. So 15 times 2 is that. I hope it is clear. Okay. Now we come to when they are different. When they are different, those that we are the same, I wrote this one just for you to see. Here we cannot avoid this step because this and this, they are not the same. So root 3 times root 5. Sword, we need a sword. 3 times 5, 15. Nothing else. We cannot avoid this because 15 is not a perfect square, except for cases wherein you can simplify it further, then you do it. But 15, there are no two numbers where one is a perfect square, it will multiply to give you 15, other than 1. Root 2, root 3, they are also different. But before we go to that, let's do those outside first. 3 times 4 is 12. Root 2, root 2. A sword. Multiplying, we need a sword. 2 times 3 is 6. 6 is not a perfect square, so we cannot avoid the root as we avoided here. So this is the result we have. Now, squaring this, don't think swords are exceptional cases to squaring values. If you say a squared, it is a times a. So likewise, root 5 squared is root 5 times root 5. So we come to this level of root 3 times root 3, 3. Root 2 times root 2, 2. Root 5 times root 5 is 5. So here again, we usually what avoid this case. Whenever you square a square root, just write this number. You don't need to come to this level. I hope it is making sense. Okay, we come to division cases here. This one is a sword, this one is a sword. There are cases that we can unite them. There are cases that we cannot unite them. It all depends the nature of the problem we are solving. So if this one has a sword, this one has a sword, just like here, we take 1 and complete this. So here we can take 1 and say 24 over 6. I hope it is clear. This and this, we use 1 sword, root, and say 3 times 5. There is a sword, there is a sword. We use 1, but this one has to be different because it's a fraction. So 24 over 6. If you can simplify it further, you continue. Here, you don't need to ask again about swords because you already did this one in the early stage of your mathematics. Wherein 6 into itself is 1, into 24 is what? Is 4. So it will not be long again like this because 4 divided by 1 is just 4. We cannot have all this whole thing. But suppose we write it, they will not mark it wrong. Because now a single number. This is 4. And square root of 4 is 2. So sometimes if you have separate sorts in a fraction, you unite them. Sometimes if you have the united one here, you have to separate them. Sometimes. Yes. But you can also work without doing it. All depends how you see the fraction. Now 9 and 12. You can see what? 3 into this is what? 3 times 3 into 12 is 4. So we have 3 over 4. 3 is not a perfect square, meaning it will not give us a result of a whole number unless it gives us 1 point something else. Well, 4 is a perfect square, so it is in the root. So the square root of 4 is 2. So this one survived going outside with the square root of 4. Well, this one has to be maintained inside. So we say root 3, square root of 4 is 2. Or if you want, you separate them. Root 3, root 4, just as I explained here. So we say root 3, square root of 4 is 2. But they are just the same. They are just the same. We come to this one. Just like when you used to expand in algebra, when you say 3 into x plus 2, you say 3 times x, 3x, 3 times 2, 6. So here again, root 3 times 2, there is 1 here. You cannot unite a sword and a rational number. You cannot unite them by saying, well, let me say root 3 times 2, 6. No, because this is not a sword. This one is a rational number. This one is an irrational number. So what we do is This is not a sort, so it only multiplies the number that is not a sort, which is 1 here. So 2 times 1 is 2. Oh, I'm here. Oh, I'm here for now. So 3 times 3 root 2. This is not a sort, it's not a sort. They are the only ones that multiply. 3 times 3, 9. Then 9 root 2. Just like we say, 3 times 1 is 3. Then 3x. So 3 times 3 is 9. That means 9 root 2 minus. Not a sort, not a sort. This one is as usual. So 3 times 4, 12. So as I was saying, not a sword, 1 is not a sword. So 2 times 1 is 2. Then we have 2 root 3. Think of this as x. X times 2, 2x plus root 3 times 2 root 3. A sword, a sword. Not a sword, not a sword. A known sword multiplies a known sword. A sword multiplies a sword. So 1 times 2 is 2. Root 3 times root 3. Root 3 times root 3. See it now? So 1 times 2 is 2. Root 3 times root 3 is 3. Is that correct? No, because this one is 23. So it has to be like this. Remember what I said here. So you can keep repeating the video, then you master everything. So 2 root 3 plus 2 times 3, 6. So this is what we have for this class. Thank you for watching. Do not forget to follow, like, share, and comment. See you in my next video. Don't forget the YouTube as well. Subscribe.